Hello, good morning to all. Today we have to study about the thermostatic expansion valve in the syllabus part of refrigeration and air conditioning system. In this video we have to cover introduction, cut section view of thermostatic expansion valve, construction of thermostatic expansion valve, figure and its working of thermostatic expansion valve. What is the thermostatic expansion valve? This is our first question for studying this topic. The thermostatic expansion valve will control the flow of refrigerant as per the requirement of evaporator or cooling load. In air conditioning system, any heavy refrigeration system, we have to use thermostatic expansion valve. This is the types of thermostatic expansion valve. Introduction. This valve controlling the liquid refrigerant is very prevalent in works with a temperature and pressure. The first topic is for cooling device is required compressor, conditioner, expansion device and evaporator. There are many more of expansion device are available. As per requirement of cooling load, we have to categorize in a different types. For an example, we have to say that we have to using a refrigeration system in our home as a domestic refrigerator. Domestic refrigerator cooling capacity is very low. Means there is no requirement of the maximum cooling. So that we have to using expansion device as a capillary tube for a low cooling load. If you have to consider for 1 ton of refrigeration or 1 ton of air conditioning system, there is a requirement of cooling load is very high. So that in this condition we cannot use as a capillary tube. At this time we have to use thermostatic expansion valve where we have to maintaining temperature of the refrigerant and pressure of the refrigerant. This valve is precision device that is regulates the rate of flow. Means the liquid refrigerant pass through the air conditioning or any cooling system. The thermostatic expansion valve control the flow of liquid refrigerant into the evaporator. Because of that, the thermostatic expansion valve are mounted between conditioner and evaporator. The flow of refrigerant is passed from the conditioner, expansion device and evaporator. That means liquid refrigerant into the evaporator system. This is the cut section view of thermostatic expansion valve. We have to know this all the notification. There is a inlet where the refrigerant can enter into the thermostatic expansion valve. Here is outlet. The refrigerant is comes out from the thermostatic valve. At this inlet condition, the temperature of refrigerant is higher. Temperature and pressure. After the throttling process, means that the outlet of thermostatic valve, the temperature and pressure are completely goes down as a negative temperature. Means there is a one type of throttling process. The pressure energy converted into the velocity energy, means kinetic energy. At this time the pressure completely dropped down and P is directly proportional to T temperature, means at this time temperature also goes down of the refrigerant. Here this circular part is a diaphragm control. There is a sense the temperature of evaporator outlet and create a diaphragm pressure into the thermostatic expansion valve. Here is a orifice are mounted and orifice is directly connected to a spring, and this spring is directly connected to a inlet of the thermostatic valve where the refrigerant can enter at this point. Here is a capillary tube. That capillary tube sends the temperature of outlet at evaporator and it's give the feedback to a diaphragm. This feedback is directly control the orifice mounted in the thermostatic expansion valve and it's balanced by spring. How many area are required to open and close where we have to controlling the refrigerant flow. Here is a inlet. Then after this is a power head. Power head means in this side there is a mounted one diaphragm which control the orifice gap to opening and to closing. How many area are required to open and how many area are required to close. This is the superheat adjustment spindle. If the refrigerant is passed through the expansion valve where is a sometimes of the some vapor are enter, most of the liquid air enter into the thermostatic expansion valve, so that is to require to adjust the spindle where the vapor are superheated. The construction of thermostatic valve. In its construction, it consists a needle valve means orifice, diaphragm, remote filler bulb which gives a feedback from the evaporator, the temperature of the outlet sense, controlling spring to maintaining a area of opening and closing of the orifice, and adjustant screw. How many area we have to maintain as a constant open or close. Here, three pressure are acting on the remote bulb pressure on the top of diaphragm. Here is a three pressure are acting. One is a diaphragm pressure. Here is a diaphragm pressure means these are directly connected to a evaporator outlet. The pressure is first. Then after the second pressure is and second and third pressure is the evaporator pressure and acting band with diaphragm means there is a outlet position and diaphragm pressure. It is a power head. Three pressure are acting on the thermostatic expansion valve. The spring extends its force bends the diaphragm through the needle valve in the closing direction of the valve. This pressure can be made by latch or adjusting screw. If this valve creating a higher pressure on this diaphragm, so it goes to a down and is controlled by the spring for requiring a area of opening or closing. The evaporator pressure is also a act against the branch diaphragm in a closing direction of the valve. Same that way, if the temperature is goes to a down, the diaphragm is gets a upward direction. We have to study near about the working of expansion valve. Here, adjusting screw for spring to evaporator means outlet. Here is a inlet, a diaphragm, capillary tube, bulb directly attached to a evaporator, and internal equalization is balance the thermostatic expansion valve. The valve controlling the liquid refrigerant is very prevalent. This works with the temperature and pressure. First we have to start from inlet of the valve. There is a point of inlet where the completely liquid refrigerant can enter. Then after that, this refrigerant pass this way and out from this way. But here is a minor area of throat are created. So we can the pressure energy converted into the velocity and temperature drop at this condition area of throat. Here this area of throat or orifice are controlled by the diaphragm. How many area of opening and how many area of our closing required to refrigerant flow. The valve is a precision device that regulates the rate of flow of liquid refrigerant into the evaporator. In extract portion to the rate of evaporation of cooling refrigerant, which is according to the heat load. If the evaporator temperature is goes to a up, means that in this total assembly the mercury are inserted in this bulb. So evaporator temperature at the outlet condition increasing, the mercury inside this capillary tube is expand. So it's a create a pressure on the diaphragm, so that this orifice area is create a more area of opening. So maximum liquid refrigerant can pass into the orifice and exist from the thermostatic expansion valve to evaporator. Means refrigerant flow can increasing to control the heat load. This also regulates the quantity of refrigerant vapor exhausted by evaporator. Means how many temperature R goes to a evaporator outlet. It's also sense this works according to temperature of refrigerant vapor leaving the evaporator and pressure in the evaporator. If the temperature goes to a down in a evaporator outlet condition, the mercury is shrink and is a normalized pressure to the diaphragm and diaphragm goes to it up, so that the spring can expand, and in case of this condition the orifice slide closed, so it can stop the refrigerant flow in this condition. So heating load is down into the evaporator. This valve control the liquid refrigerant is very prevalent. This work with a temperature and pressure. The pressure of the remote valve is equal to the sum of pressure of the spring and evaporator. The valve opened due to the remote valve pressure, but the valve start to the closing due to the spring and evaporator pressure. If the temperature of outlet evaporator condition and temperature of evaporator inlet are same, the diaphragm maintain a center position. So minimum refrigerant can pass through the evaporator. If the evaporator temperature goes to a up, so in this condition the diaphragm goes to a downward direction and is created load on a spring. In this condition, the refrigerant can pass as a maximum flow rate. If the evaporator temperature goes to a down, the diaphragm load was decreasing by the mercury shrinkage, and refrigerant flow can also decreasing by the orifice and is controlled by the spring. Working of expansion valve, it has got to following three functions in the refrigeration system. Throttling action, it's reduce the pressure. Modulating action, it sets liquid refrigerant in the evaporator in proper quantity, keeps the necessity load change in order. The valve not set by keep a constant superheat and temperature pressure in the evaporator, but it also used for a variable heat load of the system. So this valve is most commonly used in a commercial refrigeration and air conditioning system. The major advantages of this expansion valve is to control the pressure and temperature of the cooling side, means in a evaporator. So mostly used in a heavy air conditioning system. Heavy air conditioning system mostly used in a commercial refrigeration system and air conditioning system. Yeah, thank you.